Welcome back to Let's Go. Today we have this game. We've got a couple of menus here. These are using sprites. We can click a new game and choose a ship. I'm going to choose the one on the left. And then this is kind of a little asteroids game. The lasers shoot. The collision between the lasers and the meteors works. The meteor spawning in after you destroy the bigger, the medium, and then the small ones works. And then we got this little ship controller flying around the screen that is a little bit momentum based. So if you're going in one direction and you want to go in the other, it takes you a second to kind of stop and go the other direction. You wrap around and can just go off any side of the screen. And there's a couple things that still need to be done in this game, but figure we would start here. So let's start in the most straightforward place. This is the Cargo.toml. This is a Bevy game. It's using 0.13.1. We use the rand crate for some utility stuff. Bevy asset loader for loading of sprite sheets and assets. If I scroll up, you can see that there's quite a few assets here. I don't use all of them right now. I will remove some of them. This space sheet is the main asset. So it looks like this. We're using a sprite sheet. You can see that these are not oriented in a grid. They're oriented in a whole bunch of different rectangles. So we'll cover how we do that. And then we have all of the metadata about which position in rectangle each of the sprites is. We use Bevy XBPD 2D for colliders, not for physics, but just for the colliders. And then ROXML tree for, again, that asset loading that we were just talking about. So we've got the debug-plugin feature on Bevy XBPD 2D. If I run the game again on the side here, you can see the orange circle for each of the meteors. I haven't taken each of the meteors and created a polyline or anything like that. I'm using a very simple circle. It's probably one of the things I'll change in the future. And then each of the lasers, you'll probably have to pause the video to see the frames actually, but each of those have the same orange line on them to debug the colliders. So after Cargo.toml, we probably want to start in main.rs. And before we get into the code here, remember that this is a game that I built on a plane ride to and from London. So this is just kind of how I wrote it. It isn't any standard or, this isn't the best way to write a Bevy game. It's just how I wrote a Bevy game on a plane. And I'll improve it over time. So we've got this clear color that's responsible for the background color in the Asteroids game. It's this like not quite black, but a little bit blue color. That renders when we don't have anything else to render. So in this case, it's the entire background. We've got a number of plugins. This whole Bevy app is kind of organized in plugins. Basically everything down here is a plugin I wrote. The physics plugins are the exception, which is Bevy XBPD 2D, which is not mine. Then of course we've got the default plugins. We've set the window title to Asteroids. And I really tend to like organizing things in plugins like this because it means that, let's say I want to change an asset or look at an asset or something like that. If I go to the assets plugin, which is just in the assets file, we have the loading state here, some utilities that we need for actually loading some of the assets, and then some collections. So we've got all of our font assets, all of our audio assets, and all of our image assets, because that's how I decided to chop it up. But it gives me an entry point into everything, basically. And while this might not make sense for every game, I do quite like it for a lot of my code. When you write plugins in Bevy, they don't need to be third-party, like generic, super useful for everybody plugins. They can just be a way to organize a set of files. So we've got this game state that has a number of states that's defined in lib.rs. That's asset loading, the menu, the choose ship page, and then actually playing. And then a number of systems here. Setup just spawns the camera 2D bundle, default, nothing special. When we enter the playing state, we start the game. Take a look at that system in a second. And then on update, we run this laser meteor collision system. This is kind of out of place. It should probably be in the meteor plugin or something like that. Not sure where I'm going to put it. It lives here for now. We use a couple of run conditions. So run if in state, game state playing. So only runs if we're in the playing state. And then I've also got a pause system that we'll talk about, a resource-based pause system. So if a resource called pausable is in the not paused state, well, it's not really a state, it's really just a value. But if resource equals pausable, not paused, then this system doesn't run. And I like this pause system is kind of nice. I like it a lot. And then we run it. So with that out of the way, I guess the next obvious place to look is lib.rs. We've got a couple of modules. This is where all of the kind of plugins exist. This start game is the start game that we saw earlier. So again, remember we've got 4 states. We've got asset loading, we've got the main menu, the choose ship, and then the actual game itself. When we do actually start a game, we actually fire an event with the ship that the user has chosen so that we know which one to use and the position in the UI that that ship was so that we can spawn it in at that location. If we bring the game back up here, you can see left, right, and center. I don't know why I said them in that order, but we used left at the beginning of the video. So whenever this event comes in, it tells us where this ship is that we chose and which ship we chose. There's A, B, and C here. So if I click on the right, it'll just spawn in there on the right, and then we get to play with that ship. I think it's a nice little touch to spawn them in from kind of the UI location. And I'm hoping to do a little bit more like animation, a little bit more easing, like move it or move the camera to it or something like that. So we've got the event reader for the choose ship event. The choose ship event gives us the ship type and the location. We only care about one of these at a time. We can only ever process one at a time. We're never going to have 2 players. So this is how I chose to set it up. If we don't have an event for some reason, if we forgot to send it, I have this warning and then we just return from the system. I think this pattern is quite nice because it means that the game actually won't crash, which means that if we're ever refactoring something and we haven't set up that event to send yet, we can still run the rest of the game and see how the things that we have refactored are behaving. So this just early terminates the system and doesn't do anything, rather than, let's say, we could unwrap here instead, and that would cause a panic and our game would crash. I like not crashing more. Then we've got our assets here. This is the images.spacesheet. That's a handle to something we'll talk about right after this system. I think that's a good next step. But basically this gets us the sprite sheet, specifically the one that contains the ships and the meteors. So in this case, it's the ship, it's the player ship. This is a marker struct to mark the player. Got the ship type here. We've got a marker for the movement of the ship being wrapping. So that means anytime it goes out of bounds, it wraps around to the other side. And then we've got sprite bundle and texture atlas. We take the ship menu location from that event, and we use the space sheet, the sprite sheet for these space assets. This is a handle to an image that contains everything, so it's the one we looked at earlier. And then we say that there's also this texture atlas component, which says use the layout that we constructed, which takes all the different rectangles inside of that sprite sheet and uses an index to pick one out. So we're saying use this image and use the rectangle for a specific index in that sprite sheet. And then we spawn in a meteor at some place with the same like images and stuff. Overall, most of the systems in this game are pretty small. The laser meteor collision is Bevy XBB2D related. In this case, this responds to meteor destroyed events, or rather writes meteor destroyed events. So we query for all of the lasers, we query for all of the meteors, iterate over the meteors. Colliding entities right here is a Bevy XBBD2D thing. So this will get filled out with anything that is colliding with a given meteor. For every meteor, if that is empty, then we don't do anything. If it isn't empty, then we iterate over and see if there's any laser colliding with it. This needs a little bit of work. It's fine. It works. The big issue here is that if a laser happens to be colliding with, say, multiple meteors, if they're overlapping or something, because meteors don't really bounce off each other or anything, you can end up removing a laser in one loop and keeping it around and then trying to remove it again later. And if there is a collision, we say the meteor was destroyed, where it was destroyed, and what type it was when it got destroyed, which we can then listen to in another system and spawn new meteors in. So we're relying heavily on events in this game. And it's an active choice that I've made to rely a little bit more on events over time. I think they are one of the basic primitives of an ECS system, or at least Bevy's ECS system. So there's a couple other things to talk about. I think that the assets and the pause menu are probably some of the more interesting stuff. So let's talk about the assets first. I'm using Kenny assets. So you can go to kenny.nl and you'll see all of the assets they have available. Bunch of free assets, wonderful for games, wonderful for picking, you know, an asset pack and just kit bashing a small game together, getting used to a new game engine, something like that. So I was on a plane and I didn't want to draw my own assets while I was on a plane. So that's why we're using Kenny's assets. And they work out pretty great. The only downside is there's no automatic way to handle this XML file that comes with the sprite sheet. So we do have options. If we look at our assets plugin, when we init these collections or load these collections, we can go down and look at some of the collections. And we have, for example, this gray box is a handle to an image. And then this glass panel is, you know, surrounding the menu here. If we click into settings at the bottom here, which is kind of like broken layout, you can see the checkbox. So it's the gray box here, which is an image handle. And then the checked box is what we're seeing actually. So we can get individual images here brought in. We can also bring in the entire sprite sheet, which is interesting. In this case, I've written a plugin to handle those XML files and to look for the PNG files. So this is a custom asset plugin for Bevy, specifically designed to handle these exact XML files. Now you'll notice that I do have XML as the extension here. That is not the best option. The best option would be to have a unique file extension. So like .kenny.xml or something like that. I just didn't get around to that yet. So in our asset plugin, our Kenny asset plugin is what we're creating here. We initialize our new asset, which is a Kenny sprite sheet asset, and we initialize a new asset loader. Our sprite sheet asset comes with all of those textures that we just saw in the XML file. So let me bring up the XML file here. So we've got subtexture, it's got a name, it's got an X and a Y value, and then a width and a height. And if we say, for example, wanted to access one of these by its name, so all of the Kenny asset packs come with sort of these PNGs that are named individually. So if we were, say, looking through the folder and we found one we wanted to use, we could still use the sprite sheet. We could do a find in this textures sort of vec for the name and then use that index. So that's why I'm keeping the textures around like that. We have a custom struct to do that. It just matches everything that we saw in the XML. Then we also keep the sheet. The sheet is a handle to the image that is the PNG. And we have a texture atlas layout, which is the important part. It's how we translate this XML into something Bevy can actually use to pick out a region. So we need to define this asset loader and then implement asset loader for it. The error that we have here is extremely basic. I am looking forward to filling this out in the future, but for now it just handles IO errors and everything else is unwrapped inside of this implementation. We have to define the type of asset we're loading, the settings, which we have none, so it's unit, and then the error that we could return. That's the error that we just looked at. We don't use most of this, or we don't have any settings, so we don't use settings. The reader gives us the actual contents of that XML file, and the load context is how we pull in the other assets. So this load function will get called when we're trying to load this asset. We can get the original path, replace that path with an extension PNG, which means that this spacesheet XML on the right, if we look for that, then we'll replace the extension and look for spacesheet.png. Then we use this load context, which is Bevy asset load context, as you can see here. It's responsible for kind of like pulling things in and tracking dependencies. So if we say that our custom asset depends on something else and that other thing changes, this load context is responsible for doing the bookkeeping so that when that sub dependency changes, our asset changes. So we use the load function to grab that PNG and include it as a dependency of the thing we've already loaded. That gives us a handle to an image, which is, great. We kind of need that. But we also need load direct. I don't actually know if we need both of these. This is just the way I got it to work when I was on the plane. Load gives us this handle and load direct gives us the actual image. So it gives us an erased loaded asset is what the type is called. So we can take that erased loaded asset and actually get the asset. In this case, we get the image, and the image can give us the X and the Y coordinates. We need those for when we create the layout. So down here, when we create our texture atlas layout, which is all of the rectangles again, we need to know how big the sprite sheet is. We then take that reader we were given in this function and we read in that XML string, and then we use RO XML tree to do a very basic parser here. It just parses the XML and allows us to access attributes on it. So we take that XML doc, we go through all the descendants of the root node, which is all those subtextures. We make sure that we're only processing subtextures just in case something else got in there. I think in this case, there are some like empty space lines that get in there because RO XML tree is doing a specific kind of XML parsing or whatever. I wanted to deal with XML as little as possible, so I just kind of dealt with it and filtered out. And then we map over each of those elements, grab the attributes and parse them because they come in as strings, and we need U32s for the X and Y positions and the width and the height. Then we take that texture atlas layout that we created and we add a new texture. We build a rectangle from the X and Y coordinates and the X and Y plus the width and the height. This gives us that rectangle that we're looking for that identifies where each of these things is inside of that atlas. And then we create a subtexture. Remember, we're mapping over here, so this subtexture gets returned from this function and we collect it into that vec. Finally, we create a loaded asset. We make sure that you can actually access the texture atlas layout as a labeled asset. You may not have seen this before. It's more common in GLTF, but it's basically like if you were going to import the sprite sheet.xml and then you wanted the texture atlas, you could do like a hash and then the texture atlas. So this is our identifier. This is the content, and that gives us our sprite sheet. So now we have all of the textures in a vec. We have a handle to the image, and we have the texture atlas layout. So all we ever need to do if we ever want to access all the stuff inside of that sprite sheet is use this Kenny sprite sheet asset. And that's exactly what we're doing here in our start game that we just talked about. So we're getting the images, which is that image assets struct that we looked at. And this is the assets database for all of the sprite sheets that we could have imported at all. Images.space sheet, as it were, is going to be the handle to the Kenny assets struct. If we look at assets.rs, we can see that space sheet is that space sheet.xml, and it does give us a handle to that struct that we just looked at. So this is the struct with all the information that we wanted. So from that assets database, we get the asset that we want using the handle. That gives us this space sheet, which is the reference to a Kenny sprite sheet asset, which we can then use as the texture, which is just the handle to the image, as the layout, which is the texture atlas layout, and then we get to pick an index, any index. I'm pretty happy with this. I might turn it into like a third-party usable plugin. I use Kenny assets fairly often, so I'll probably at least build one that works for my use cases. But I'm pretty happy with this overall as a kind of like short dive into building custom assets and custom asset loaders. The system is pretty flexible, although it is a little opaque if you don't know which loads and, load direct and things like that to call. But the types always have the documentation. So for example, if you needed to know what you could do with an erased loaded asset, well, go to the erased loaded asset in the docs. It's got asset type IDs, gets, iter labels, take, etc. And it's the same thing for load context. All of these functions have a little bit of documentation on them. If it's not enough documentation for you, definitely file an issue on the GitHub repo for Bevy so that the documentation can then get updated. So other than that, it's basically a ton of systems. The pause system is probably the most interesting. If we go ahead and run the game again, pick a ship, maybe make it a little bit more obvious that things are moving around the scene here, and then hit enter, you can see that the game has been paused. If I hit enter again, the game keeps going, game paused, everything stops, keeps going, and so on. So all of this logic is in the pause.rs plugin. The pause plugin adds a couple of systems. We've got a handle pause toggle. So basically if you hit enter, should it pause or unpause? And then we're listening to the resource to either show or hide the pause menu. In this case, when we show the pause menu, we check to see if the resource changed, which is the pausable resource. And then we check to see if the resource is equal to pausable paused. If it is, then we show. Otherwise, in the opposite direction, if it's not, we hide. And we start off the game as not paused because this doesn't matter until the user has hit paused for the first time. Pausable is just an enum. It's got paused and not paused. Chose to go for clarity instead of paused and, playing or something like that. The handle pause toggle system is very simple. It takes key code inputs and that resource that we talked about. If you just pressed enter, then it toggles that resource between paused and not paused. I really enjoy how simple this system is because you hit a key and it changes the resource, and then we can queue up everything else to react to that resource. So for example, our hide pause menu is just despawning everything that we constructed for the pause menu, and that only runs in response to that resource changing. And then show pause menu is the opposite. It constructs the pause menu using, again, some of the images from our assets that we just talked about. We do use 9-slice scaling, which keeps the corners crisp while stretching out the longer parts. This is a fairly recent addition to Bevy. It's something that is really nice and that I was really missing before it didn't exist. And then finally, the important part here is this pause menu ID. We stick that into this struct called pause menu. That's how we know what to despawn later when we hide it. So we're looking for this res pause menu, or this pause menu resource, which contains that ID. So whenever we want to hide it, we just destroy everything. The other pattern I've been getting into lately for UI specifically, you can see this is a bunch of like image bundles, text bundles with children. This with children is how I used to set everything up, and it's fine. It's kind of how I'm used to doing things on the web, where you would kind of have like an outer image tag or an outer div tag, and then like children inside of that div that were paragraph tags or something like that. And then, I don't know, more inside of that. So you get this like stack of divs and sections and whatever. I think in Bevy, because we're spawning entities, so we're using commands.spawn, which is the same thing we use to spawn in, sprites for our ships and the meteors and everything else. There's actually an interesting pattern here where if you spawn a node bundle, you can then add a child you've already spawned. So in this way, you get to kind of just create all the entities in your system and then put them together later. I kind of like how this fits together. It is a little bit more disjointed, but it does mean you don't get into kind of like super nested with children, because in more complicated UI, you're going to have a lot of these like children elements, right? The UI is complicated and it's a deep tree quite often. The player movement system lives in controls. It is monolithic at the moment. I'm going to switch it to use this library called Leafwing Input Manager. Leafwing Input Manager is a pretty robust input sort of action mapping tool. I really quite like it. Whenever my needs for my Bevy games get more complicated, or I want to split things up a little bit more, I reach for Leafwing Input Manager. In this case, the player movement system is just everything you can do with a ship. So it's turning to the left and turning to the right and also shooting for some reason, and etc. So like anything that you can press on a keyboard is directly read in this system and then executes whatever it's going to do. I would like to add support for example, a controller. I think driving a ship with a controller makes a little bit more sense, or will be a little bit more fun, a little bit easier. Plus, being able to kind of remap buttons makes games more accessible, is my understanding anyway. So for example, if you have button remapping controller support and you ship something on Steam, people can remap those buttons to accessibility inputs, and it allows more people to play and enjoy your game. So that's something that I would like to keep in mind. The other thing is that from a code organization perspective, having all of the keyboard input read in this system and also the things that are happening in response to those inputs in this system makes it one of the more monolithic systems in this game. And I don't particularly like that because there's a bunch of things that are just flat out not related other than the fact that they are in response to input. So for example, we've got left and right here, right? And they only affect the rotation factor. So this whole section is just rotation. And then we randomly right below that have, should we shoot or not, right? Should a laser come out of the ship or not? And we've got like a delay on how often that can happen. So these things are kind of like competing for both code space and operating space, right? Every time this system runs, we have to first do rotation before we can do like laser shooting or before we can do forward movement. And they're not really related. None of those things are related, right? Like forward movement, left and right, and lasers are all distinct concerns, and they don't need to be in the same system. So I would like to make that improvement in the future. The movement for other things is pretty simple, and I'm pretty happy with it. So this is a movement plugin. We've got linear movement, spinning movement, and wrapping movement. Linear movement is based on the logic that I wrote for the lasers. Anytime you have a thing in the scene moving in one direction consistently, it's linear movement, or what I'm calling linear movement. So all you need to do is create this component with a movement factor in some direction and some speed. And we take all of that and we move it forward that distance over however much time has passed. We bind this to time and not frame rate, so that if you run a slower frame rate or a faster frame rate, it doesn't move in different ways. Same thing for spinnable. You just add this spin component, how much spin should be happening, per second effectively. And then we loop over everything that's spinnable. We query for all the spin components with a transform. We rotate them based on how much time has passed and how fast they're supposed to spin, and they start spinning. Same thing for a wrapping movement. This is the way that we get the ship goes off to the side and comes on the other. The meteors go off the top and show up on the bottom. The lasers do the same thing. So everything is based on this wrapping movement component. So anything with a transform that has this wrapping movement component will now wrap when it hits the window edge. And this kind of isolation is really nice because it means that anytime we have anything that needs to wrap, all we need to do is add the wrapping movement component. It also means that, say, what if we wanted to have, for example, a boss, and the boss needs to come in from the top and enter the scene? So if it's off the scene, it can't have the wrapping movement behavior, right? So we don't want the component on it. Once it reaches the screen, maybe we do want it to wrap because we want it to stick around. So we can then, once it gets into the scene, put this component on it, and then it will wrap at that time. So it allows like this component-based API where if the component exists on something with a transform, then it will wrap. And if you don't want it to wrap, then don't put the component on it. Or remove or add the component at different times to make different things happen. I think that's pretty much it. There's this SpawnButton struct. I don't know if I'm going to keep this. It's a little bit interesting if you're interested in building your own commands. The usage for that is in the UI, because inside of that original menu that we saw, I want to add a couple of buttons. I want all the buttons to be the same. I want them to lay out the same. So I do this with children parent thing. I think that I'm going to try to switch this to add child. Then I don't need to do this parent entity piece, which always felt pretty awkward, honestly. Player ship type is defined as A, B, or C. We've got an index into the sprite sheet for what the base ship model is. This will probably expand to include the damage models, and I think I want to split up the movement and the rotation speed. So this is a base movement and a base rotation per ship, so we can have like A be faster forward, but less rotation speed, and B be, fairly balanced, and then C have like really fast rotation and not so fast base movement. There is an example for using the sort of Kenny asset plugin loader, so feel free to take that code and do whatever you want with it. And then there's a second example called Kenny.rs that shows how to load one of these sprite sheets using the asset server and not using Bevy asset loader, because it really doesn't matter if you load it via the asset server or you load it via Bevy asset loader. It should load the same either way. You just do have to keep a handle around to it, or like store it in a resource or a struct to keep it around. So that is this little Asteroids game. We've got this main menu with the settings. We can create a new game, choose a ship, drive the ship around, fire lasers at meteors and have them hit. There's a meteor bundle that we didn't cover and a couple of other things, but nothing too intense, especially if you've built Bevy games before. Of course, the colliders all work. There's a number of different sprites being used for meteors and things like that. And then there's some work that I still need to do. Like this ship needs to have a collider. We need to have a life system, right? If the ship hits a meteor, it should remove a life. You should get 3 lives or something like that. Maybe we'll implement UFOs. UFOs are a feature of Asteroids as well. I'm going to take this project in 2 different directions. One of them is going to be like regular Asteroids as a workshop, and the other is just going to be kind of a ship, maybe a roguelite ship Asteroids kind of situation. I don't know exactly what that's going to be, but it sounds like fun to build kind of a roguelite based like laser upgrade and movement system. So we'll see how that goes. And I hope you enjoyed this iteration of Let's Code for Asteroids. The code will be linked in the description, and I will catch you in the next one. Have a great rest of your day.